Welcome, ladies and gentlemen. Today we're going to be talking about the basics and properties of waves. We're going to start by just going through our notes line by line. So in physics, a wave is known as a disturbance that travels through space and matter, transferring energy from one place to another. There are two types of waves present in everyday life. That's going to be sound and light. And all waves can be categorized as either mechanical or electromagnetic. Mechanical waves require some sort of matter to travel through. This means that they could not travel through a vacuum. Some examples of mechanical waves could be sound waves, water waves, or seismic waves. Seismic waves being like an earthquake. Electromagnetic waves can travel through a vacuum or empty space. Two examples of electromagnetic waves might be light, microwaves, radio waves, or X-rays. A transverse wave is waves that move from left to right, while the disturbance moves up and down. Longitudinal waves are where the disturbance moves the same direction as the wave. We're going to draw a transverse wave in the box below. There's our transverse wave. Take a second, copy it into your notes. The next thing we're going to do is we're going to be looking at properties of waves. So we're going to start by drawing a wave labeled with the crest, trough, time or distance, and the rest position. We can see our wave here. It's the same type of transverse wave we drew on the Basics of Waves page, but up here we have our crest in red. We have the rest position, which is this base line that the wave has to cross. A trough in blue, that's the bottom of our wave. And the time or distance, which is just the entire path that the wave can follow. The highest point on the wave is called the crest. The lowest point on the wave is called the trough. The amplitude of the wave measures the strength or intensity of the wave. The amplitude of the wave will also measure the loudness of the sound. So if we increase amplitude, the sound's going to get louder. The wavelength measures the distance between two corresponding points, such as two crests or two troughs. We're also going to want to draw a wave labeled with the amplitude, wavelength, and distance. So we just talked about what amplitude and wavelength are. So we're going to draw the same transverse wave, and we're going to put amplitude in two different places and wavelength in two different places. We're going to put the amplitude first, and we have it from the rest position all the way to the crest. That's our amplitude. Or we can also have it from the rest position all the way to the trough. So you can see we have it in two separate locations on this wave. And our wavelength, we said, measures the distance between two corresponding points. So if we have it from two crests, or we can have it from two troughs. The distance, once again, we're just going to draw. It's the entire path of the wavelength. The time it takes to get there can also be considered the distance of the wave. Now, the frequency of a wave is the number of times per second the wave cycles. The period of a wave is the time between the wave crests. Finally, the speed of a wave is how fast the disturbance of the wave is moving, which depends on the medium or the matter that the wave is traveling through.